Here's your Unit 2 study guide on dilations and similarity explained. For question 1, we must decide which of these triangles must be similar. So before we begin, let's review what the word similar means. So a similar figure has the same shape, and then the size can be enlarged or reduced, and it must be proportional. So let's look at question 1. Triangle 1 has a 90-degree angle, and triangle 2 has a 90-degree angle. And our hint is to sketch a picture of each. So let's do a little sketch. There's a triangle with a 90-degree angle. And here's another triangle with a 90-degree angle. And to be similar, all these angle measures must be the same, all three. So we know for certain that they would both have a 90-degree angle, but the other two angles could be different measures. So we can't say for sure that question number 1 would be similar. Question number 2. Triangle 3 is isosceles and has a 50-degree angle. And triangle 4 is isosceles and has a 50-degree angle. Okay, so isosceles means that two angle measures are the same. Okay, so let me draw two triangles. And it says that it has at least one 50-degree angle. So if I made this first triangle with a 50-degree angle, and all three would have to add up to 180, that's 100, so this would be 80 right here. But I guess I could say that this angle would be 50 to satisfy that requirement of having a 50-degree angle, which would be 130 degrees left over, which would mean that these two could be 65 and still be an isosceles triangle. So at first I thought this one would be true, but I was able to make two isosceles triangles that have a 50-degree angle. So I'm going to say that this one is not true in all cases. Okay, let's go on to the next one. Triangle 5 has a 40-degree angle and an 80-degree angle. And triangle 6 has a 40-degree angle and a 60-degree angle. Okay, so I'm going to draw those two triangles. I don't have a lot of space here, but I'm going to go 40 and 80, so that's 120. So 180 minus 120 would give me 60 for that third angle. So that's triangle 5. And then triangle 6, I have a 40 and a 60, so that third one would have to be 80, because 40 plus 60 is 100. I need 180. So this one is true. Okay, so we found a true one. Let's check the last one. Triangle 7 has a 40-degree angle and a 35-degree angle. Okay, so I'm going to go 40 and 35. And then triangle 8 has a 40-degree angle and a 115-degree angle. Okay, so 40 plus 35 is 75. So over here I have to do 180 minus 75 to see what that leftover angle would be. And that would be 105. I don't think this one is going to work out. Okay, then on triangle 8, I'm going to do 1, 15, and 40, which is 155. So let me subtract that from 180 to see what that last angle is. And that is 25. Okay, so these are not similar because they both share the 40-degree angle, but our other angles do not match up. So the only one that for sure works is the third one. Okay, so we've discussed this a little bit. To be similar, they have to have the same shape, which means the angle measures are the same. So those angles all correspond. And then the side lengths need to be proportional. So it can be enlarged or reduced, but the side lengths must be proportional. If these two shapes are similar, what is the measure of the missing length m? So we're looking for this side length right here. So let's use what we know to find out what we don't know. So to go from a 6 down to a 3, we have to figure out what that scale factor is. It seems like that's half the size. So 6 times a half would be 3. So I would use that same scale factor and cut 2 in half, and that would become 1. So our measure would be 1. Okay, so for this one, we're seeing if the shapes are similar. I did notice if I were to flip this one around, I can see right away that all of the angles do match up. So step 1 is kind of see, do they have corresponding angles? See that arc? That single arc means those are all congruent. And then this double arc means that those are congruent. So far it looks good. The angles are congruent, so it could be similar. Now I want to see if the sides are proportional. So now I see that the 25s correspond with the 15. So I'd have to figure out the scale factor there. So 25 times the scale factor would give us 15. So I would divide by 25 to get my scale factor. And 15 over 25 would simplify to 3/5. So let's do the same thing for the other side, the 20 and the 12. So I would do 20 times the scale factor would give us 12. So I'm going to divide by 20 to get the scale factor. And 12 over 20, if I divide the top and the bottom by 4, would also give me the scale factor of 3/5. So the sides are proportional and all the angles are congruent. So I'd have to explain that in my work. Okay, so I wrote a little statement there that the angles are congruent and the sides are proportional. Graph the image of triangle FGH after a dilation with a scale factor of 2 centered at the origin. If the scale factor is 2, that means it will enlarge our original image. So to perform this dilation, EGH, we would first have to look at the original ordered pairs. So F is currently sitting at -5 and +3. The letter G here is sitting at +5, +3. And H is at -5, -5. Since the scale factor is 2, I would multiply each number by 2 to get the prime. So F prime, so -5 times 2 would be -10. And 3 times 2 is 6. Okay, so G prime, I would multiply everything by 2, so that becomes 10 and 6. And H becomes -10, -10. Now, once I have the ordered pairs, I just use those ordered pairs to graph the figure. So -10, +6. F prime goes right here. And +10, 6 is over here. That's G prime. And -10, -10 right here would be H prime. So you can see that the figure doubled in size because our scale factor was 2. And then I neatly connect all those points and you can see how it is doubled. So what observations can we make about the angles? I can see they all are corresponding. If I actually got a protractor out, they're all the same angles. Or you can say corresponding. And then the side lengths should be proportional. So I'm going to count one and we'll see if it's double the size. So looking from F to H, that is 8 units tall. So this one should be 16 if it's double the size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we would say our sides are proportional. Or we could say the sides are double in size because of the scale factor. Okay. Okay, now we're going to perform another dilation with a scale factor of 1/3. So this will become 1/3 the size. If our scale factor is less than 1, it reduces the figure. So let's look at our original ordered pairs. So E is sitting at 6, 3. F sits at 6, 9. And G sits at -6, 9. So our scale factor is 1/3. So we can multiply every digit by 1/3. And just a reminder, multiplying by 1/3 is the same as dividing by 3, if that's easier for you. I'll show you both ways. So 6 times 1/3, I would put 6 over 1, and then just multiply across. So 6 times 1 is 6, and 1 times 3 is 3, and 6 divided by 3 is 2. So for E prime, I get 2. Or I could divide by 3. I could do 6 divided by 3, which is 2. So multiplying by 1/3 and dividing by 3 are the same thing. So whatever you would like to do there. Okay, so 3 divided by 3 is 1. Okay, so F prime, 6 divided by 3 is 2, 9 divided by 3 is 3, and G prime, -6 divided by 3 is -2, and 9 divided by 3 is 3. Okay, or multiply each one by 1/3. It's really your preference. Now we're going to go ahead and plot that. So 2, 1 is here for E prime. 2, 3 is here for F prime, and -2, 3 is here for G prime. So you can see that it reduced by 1/3. It's 1/3 of the size. And then down here we would write our ordered pairs of the primed image, or the dilation. Okay, so I'm just going to put these same numbers in here. Okay. All right, so keep in mind, if the scale factor is a fraction or less than 1, it reduces the figure. And if its scale factor is larger than 1, it enlarges the figure. Okay, and for our vocabulary check, your choices are angles, side, congruent, and similar. So blank figures have blank corresponding blank, and proportional corresponding blank lengths. You should have come up with similar figures have congruent corresponding angles. The angles are always the same, so they're congruent, and proportional corresponding side lengths. So go ahead and make sure you fill yours in the same way. Similar figures have congruent corresponding angles and proportional corresponding side lengths.